Hi, today I want to talk to you about one of the most recent and incredible advances in training 3D Gaussian splatting in 2026. So, this paper was approved and highlighted in CVPR, and it's called FastGS. And what they're doing is training 3D Gaussian splatting in almost hundreds of seconds. So if you have been using to training Gaussian splattings on your computers, you know that the vanilla one takes somewhere between 20 minutes to a few hours, depending on the GPU that you have. But now FastGS is here and they reduce the time by so much that it feels like a dream. So, what I'm gonna do today is that we are not gonna go through the paper itself. That is for another episode. Today, I'm just gonna go through installing and cloning the repo and showing you how to go from a video that you have captured to a 3D Gaussian splatting that you can see it on any splatting viewer. So we're gonna start from the GitHub. So if you go to the GitHub, you can see their code base. They have a specification and updates here and the future things that their team is going to develop. I'm very excited for these. So it says talks about the hardware requirements. So you need to have a CUDA ready GPU. The paper uses a 4090. On my computer, I have a 2080, and that's one of the things that I want to show you that even with a 2080 Super, this works amazingly fast. And so I only have 8 gigabyte of memory, and I'm working on a data set that is not going to cause me to get out of memory error. You need to have Conda installed, you need to have a C++ compiler, and you need CUDA SDK 11. Um, And so before you do anything, make sure that you have these compiler versions available. And then we're gonna go git clone, go to the folder. They have a very nice setup that they specify, so you just can easily install everything you need using these commands, and then you can see how the data organization is. In this case, we are not going to use their data sets. I'm going to show you how you can use Colmap to change your video into images, and then from those images, train your own data. And you have the information for training and evaluating. So they have a couple of interactive viewer that they suggest, so you can use Super Splat. For this video, I'm gonna use so for this video we can use Super Splat. There are also other splatting base. So another splatting viewer that I like that is online is the antimatter splat viewer. This is very basic but works really well, and I like how the animation is in the scene itself. So let's just start by opening a command prompt, and from here we're just gonna clone the git. So it's gonna take some time to clone. And then when it clones, we can do a dir to see everything is in there. Yes. Uh, then we need to create our conda environment. So I created my own build submodule that I rather go through that. So you want to give your path of the CUDA and your path of the virtual environment here, and then you want to cd into the um, folder. You want to set up your CUDA home, CUDA path, and these are just to just make life easier. And then you tell where's the path to the repo that you installed, and then you just do conda run fastjs, and it's automatically like the fastjs installer has the torch and the Gaussian, and it's gonna start. And at the end you want to do like a GPU torch print to make sure that you have a GPU available. So, and then to run fastjs, what you want to do is, so this is another script that's available. um so you want to show it where your scene name is and where the output is going to be. So this is where you need to put your colmap repo output, and your output is gonna land here. You want to make sure here that you have simple KNN, you have fused SSIM, and you have the Gaussian rasterizer. If this is not working, your training is gonna fail. And the next thing you're gonna do is colmap. So you have a video I can show you here. So this is like a sample of the video that I got from a bench, if it loads. And I just walked around this bench, and it's not even like my hand is shaking. It's not even a good video. So we are gonna run that, and it's a very short video. It's like 30 seconds. So what we gonna do, you want to make sure that you have colmap available, and then you want to run colmap on this. So what you're gonna do is, first you're gonna break your video into images. So I use ffmpeg to do that, and you give it your video, and you tell it how many frames per second you want it to break, and what the name, like naming convention for the images, it's gonna be. And then after that, you want to run colmap on it. So when the images drop, then you point it to the place that the images are, and you get the colmap repo and you do Python convert. And then it's gonna take care of the whole thing itself. So if colmap fails or your images don't have enough overlap, you're gonna get this kind of error. And if you're getting this, it just means that your frame rate that you're cutting the video is too low. So you want to choose a higher FPS. So you want to basically have more samples taken. And the final and the last thing is training. So I only have 8 gigabyte of RAM, so it's not 24 gigabyte of RAM that it's got, but I still could make it happen. You can assign the resolution if you don't have a lot of memory. So you can do R2, or if it's at more of a current, you can do R4. So basically it's like half a resolution or quarter of the resolution. I managed to get the whole thing with R1 on this, and we are gonna see the final results soon. So what you're gonna do is you just do Conda fastjs, and then you do Python train. So this is the training, and you share where is the inputs are and where are the outputs, what is the resolution, and what's the data device. You want to set the densification interval at 500. So it means that like at every 500, it's gonna do densification. And the test iteration is 30,000. Usually at 30,000 is the number of iteration that Gaussian splatting converges. But at 7,000, like if you want to do less iteration to make sure like everything is working, you can do like 1,000 iteration, see if you get anything, pipeline works, and then commit to the 30,000 for the full pipeline. So that's all of it. When you run all of this, you are going to get, if I go here in your scene, these are the files that are there. So in my output, I'm gonna get, this is the R1 scene that I got. And if I go to point cloud 30,000, I can get this ply file and drop it into this viewer. And here we got the reconstruction of the image, and you can use the mouse to move around the scene and just looking everywhere. Looks really good. Another interesting thing that happens that I think is really cool, and it shows that like how your selection of the frames affect things, is I take these for b-rolls, but let's look at this ground truth versus what was rendered. This is pretty impressive. And then this is the R1 ground truth. So this is like running it at full resolution. So at some point you can see my finger gets into the frame, but then like it's not in the reconstruction, which is, it shows that like how densification and pruning helps, that like the objects, this object is not seen from like other views. So it's kind of like it's gonna be gone during the pruning and densification stage, which is really cool. So thanks for listening to this tutorial. On another episode, we're gonna talk about the paper itself. I hope you can make your own Gaussian splattings really fast now. Thank you.